Hi, smart learners. Welcome to today's video on logarithm. Logarithm. So, if probably, peradventure, you have not watched the video on indices, it's actually advisable that you go through indices before logarithm because logarithm you need some ideas of indices to actually manipulate logarithm. So, logarithm is also a simple aspect of mathematics. So, but before we start, we need to explain something about logarithm. So, when I have a log of a number, I'm going to have the number here. I'm going to have the base here. So, n is standing for the number and b is standing for the base. So, I can express a number like this. I have log 4 base 10. That's how it is read. Log 4 base 10 or log 2 base 10 or log 2 base 3. So most of the times you can have just log 4 or log 6. So if the base is not specified, the base we are going to choose is going to be base 10. That's the natural base. So we just agree that okay, since there is no base is specified, we just choose what? Base 10. As simple as that. Base 10. So if that is properly understood, then we can actually move to the laws of logarithm because we need to understand the laws before we can actually start manipulating. So the first law is the addition law. Addition law. And this law states that whenever you have log of a particular number to a particular base, plus log of another number to that same base. Note, it has to be the same base. It has to be that you have base A here and you have base A here, or you have base 10 here and you have base 10 here, you have base 5 here, you have base 5 here, before the log can hold. And also you have what? An addition sign in between the two logs. So in this case, to manipulate between these two logs is just that you pick one of the log to that common base and you multiply the powers. X times y. You multiply the numbers rather. X times y. So let's take an example. I have log 5 base 10 plus log 2 base 10. So it's as simple as saying since they have the same common base, base 10, and we have an addition sign in between, we can just pick a common base, log to the common base, and do 5 times 2 and multiply the number. So we have what? Log 5 times 2 is 10 to base 10. Also, if I have log 25 base 10 plus log 4 base 10. So I'm just going to pick the log to the common base and multiply the numbers. 25 times 4. So I have what? Log 25 times 4 is 100. Log 100 base 10. Okay, we'll come back to the solution to this. It still has a further solution, but we haven't gotten there yet. So addition law, that's the first law. Now let's look at the second law, subtraction law. So just like we have for addition law, if I have the log of a particular number to a particular base minus the log of another new number to the same base, it has to be the same base, and also it must be that we have what? A negative sign in between. So in this case now, we are going to pick the log of their common bases and do x over y. We are going to divide in this case now. We are going to divide in this case. Now let's take, for example, I have log 28 base 4 minus log 14 base 4. In this case now, since they have base 4 in common and we have a subtraction sign in between, we can pick the log of the common base 4, and divide the numbers. If you have a negative sign, you divide. If you have an addition sign, you multiply. So we do 28 divided by 14. So 14 here 1, 14 and 28, that's 2. So we have what? Log 2 base 4. Log 2 base 4. Let's look at another example. I have log 6 base 2 divided by, sorry, not divided by, it has to be minus, not divided by, minus log 3 base 2. So we do what? We pick the log of the common bases, log 2, and we do 6 divided by 3. So 6 is 3 is 2, so we have log 2 base 2. Log 2 base 2. Okay, let's look at the third law, which is referred to as the power law. Power law. So the power law now, if I have, for example, I have the log of a particular number to any base, but this number x has an index form. From indices, it means that I can express x in simpler form. For example, I have log 8 base 2. Log 8 base 2. Now, you all agree with me from indices that 8 can be expressed as what? 2 raised to power 3. So that is what I mean by what? By that. So in such a case, I'm going to have log 2 raised to power 3 base 2. So instead of writing log 8, I'm just going to write what? Log 2 raised to power 3. So if that number now has a power, we can move the power to this side. So that means we are going to have 3 log 2 base 2. 3 log 2 base 2. Let's take another example. I have log 81 base 3. So I can simply do log, since 81 can be expressed in its index form, so 3 raised to power 4 base 3. So I can move 4 to this side. So I'm going to have what? 3, sorry, not 3, 4. So I'm going to have 4 log 3 base 3. So that's the third law. Now let's look at the fourth law, law number 4. So in law number 4 now, I have the power of the base. The power of the base. Now, in this case now, the base is the one that can be expressed in what? In index form. For example, I have log 2 base 8. So 8 can be expressed in its index form. Yes or no? So I can have log 2 base 8 is 2 to the power of 3. That's the index form for 8. So in such a case now, I'm going to move this 3 to this side also. But since it is the base, you can see how irregular this pattern is. It's not that smooth, unlike moving like this. So in such a case, we have to represent, we are not going to take the 3 as 3, we are going to bring the inverse of 3, of the power. So we'll be doing 1 over 3, because it is for the base, not the power. 1 over 3 then log 2 base 2. Also, if I have log 3 base 81, I'm going to have log 3. Then 81 can be expressed as 3 to the power of 4. Then move this 4 to this side. Since it is the power of the base, it's going to come with a 1 over 4. Then log 3 base 3. That's the fourth law. Now, over to the fifth law. The fifth law. So we call this law the log to its own base. That's the log of a number to its own base. So the log of a number to its own base is 1 in mathematics. So if I have log 10 base 10, that's 1. Log 4 base 4, that's 1. Log 100 base 100, that's 1. So that means that we can quickly equally go back and finish off solving from our starting point. Let's start from the beginning now. Here we have log 10 base 10. That means that the solution to this is 1. Here we have log 100 base 10. Now, you agree with me that log 100, I can do log 10 raised to power 2 base 10, because 100 is 10 raised to power 2. So I can move to this side. So I'm going to have 2, because it is for the number, not the base. It's going to be 2 without any 1 over. So I have 2 log 10 base 10. So 2 log 10 base 10. So I have 2 times 1, which is 2. Good. Here also I have 2, 4. So here you agree with me that I can express log 2 base 4 because 4, so I'm going to be using the red ink so that we are able to accommodate this. So I can have log 2. Base 4 is 2 to the power of 2. So I'm going to bring it to this side. So I'm going to have 1 over 2 log 2 base 2. So log 2 base 2 is what? Is 1. So I have what? 1 over 2 times 1, which is what? 1 over 2. Also, here log 2 base 2 is just 1. So I'm just trying to finish off all what we started with. Here we have 3 log 2 base 2. So we just have 3 times 1 because log 2 base 2 is 1. So we have our answer to be 3. Here we have 4 log 3 base 3. So that's just 4 times 1, which is what? 4. So here we have 1 over 3 log 2 base 2. So that's 1 over 3 times 1, which is 1 over 3. Here we have 1 over 4 log 3 base 3. So we have 1 over 4 times 1, which is 1 over 4. Okay. So with this solution, you can see that we were able to finish off all what we started with. Log 10 base 10 to the log of a number to its own base. So if you have log Neuma, for example, to base Neuma is equally 1. Log smart to base smart is also 1. So the log of a number to its base is what? Is 1. Now let's look at another different assumption in logarithm, which is the log of 1. Log of 1. So the natural log of 1 is 0. The log of 1 to any base is 0. So if I have log 1 base 10, that gives 0. Log 1 base a, that gives 0. Log 1 base 5, that gives 0. So whenever you take the log of a number to its base, that gives us what? It gives us a 0. So we are gradually coming to the end of the laws. Law number 7 is what I call reciprocal law. And this law are actually very important when you want to manipulate. Reciprocal law. So if I have log x base a, and I want to change the number into base or the base into number. So I want to have x as the base and a as the number now. So what I need to do is just to introduce 1 over. So once I bring in 1 over, then by default, my number is going to become the base and the base becomes the number. So I'm going to have a base x. Now let's try and use that method to solve this question. Log 3 base 81 and see if we are going to get 1 over 4. Quickly, let's see. So let's solve log 3 base 81 and see if we are going to get what? 1 over 4. So I have log 3 base 81. So the first thing is I want to switch. I want 81 to become the number and 3 to become the base. So I'm going to do 1 over log, then 81 is going to become the number, then 3 becomes the base. Now you know how to continue further. So I have 1 over log, express 81 as its index from that's 3 to the power of 4, and you still have base 4. So move 4 to this side. So I have 1 over 4, then log 3 base 3. Now, we all know that log of a number to its base is 1. So I have 1 over 4 times 1. Because log 3 to base 3 is 1. So I have 1 over 4. Voila. So I have my answer as 1 over 4. So reciprocal law is very, very important when you want to manipulate and you want to actually get in-depth knowledge. And there are times whereby you just need to always use the reciprocal law. All right, let's look at the last law for today's class, which is the last law in indices in logarithm manipulation. So this law is referred to as change of base, law number 8, which I call change of base. Change of base. So if, for example, I have the log of a number to base, and I want to change this log and the number, I want to change it into a new base. I want to have a new base. I don't even want to have base A. So it's very, very simple. What I need to do is just log x to that new base over, now this a is now going to be a new number, over log a now to that new base. Initially we have log x base a, but now we are now having log x base b as well as log a base b. Now let's apply that in the last question we solved now and see if we are going to get the same answer. So we have log 3 base 81. Now let's change the base into something new. Let's change the base into base 8, into base 10, yeah, base 10. So I'm going to have log 3 base 10 over log 81 base 10. Yes, you can see this is going to have its own new log. This is going to have its own new log to the new base. So now I can continue further by doing log 3 base 10 over log 81 is 3 to the power of 4 base 10. So I can move this 4 to this side so I can have log 3 base 10 over 4 log 3 base 10. So log 3 base 10 over log 3 base 10 is just like saying you have 2 over 2. So what do? You can cancel out this here 1, this here 1. So I have what? 1 over 4, just like we have in the other examples. So you have to ensure that you have a full grasp of all these laws before you can start solving questions in logarithm. So also endeavor to check the video on indices is very, very important. You need to check the video again. And logarithm, like I said, is very, very simple. In our next class, we'll be looking at examples on what we have learned. And in subsequent class, we'll be looking at exponential logarithm, whereby we have exponent, or equational logarithm, where we need to solve a particular value for x, or a particular value for y, or for a particular unknown. So see you in the next video. Do not forget to give us a thumbs up for this video if you enjoy it. And also if you have a question, endeavor to ask in the comment section or with the teaching assistant. Thank you and see you in the next video. Bye.